2 over 5. 5 here 1, 5 here 1. So our R will definitely be what? Root 2. So we go to our option and see the one that matches this. Our common ratio is root 2. So that is option A. Then the number 8 question says that the nth term of the progression. This aspect is a very technical aspect. So I will show you the simplest way to solve this particular problem without wasting a lot of our time. So in this situation, we have 4, look at the trend, 4 over 2, comma, 7 over 3, comma, 10 over 4, comma, they will have 13 over 5, comma, and it goes on. Let's consider the numerator. What is happening in the numerator? Numerator has 4, 7, 10, 13. Then our denominator has our denominator is, okay, let's say our numerators are 4, 7, 10, and 13. Then our denominators are 2, 3, 4, 5. If you look at this very well, you discover that this one follows a pattern, because we can see that 3 plus 4, 7, 3 plus 7, 10, 3 plus 10, 13. You can see that that follows a pattern. So what it simply means is that if I decide to say 3n, for example, where my n is now equals to 1. So 3n plus 1, for example, let me say 3n plus 1. So what am I trying to say? What I'm saying is that if I say 3 times 1 plus 1, that gives me 4. Then if I say 3 times 2 plus 1, that gives me 7. I hope you are following. Then if I say 3 times 3 plus 1, that gives me 10. Then I have 3 times 4 plus 1, that gives me 13. So you can see the trend. That means that the pattern of all this is what? 3n plus 1. That's the pattern. Then let's consider, so I've been able to detect the pattern to which this numerator follows, or the numerators follow. So in this, let me now talk about the denominator. The denominator, I have 2, 3, 4, 5. Let me see this too. If I say n plus 1, what am I saying? I'm saying 2 plus 0, that's 2. 2 plus 1, that is 3. 2 plus 2, that is 4. 2 plus 3, that is 5. You can see what I'm talking about. So in this situation, I have 2 plus 0, 2. 2 plus 1. So what's the trend? There is increase in what? So you have 1 increase, because these ones are constant term. These ones are constant, but there is increase in. When you add 1 to this, you have 1. 1 plus 0, 1. 1 plus 1, 2. 2 plus 1, 3. You can see. So it is n plus 1 pattern. So the numerator is 3n plus 1, while the denominator is n plus 1. So let's go to our option and see what our Tn will be, that the n term. So the n term will be 3n plus 1 over n plus 1. So let's go there and see. So which one will fit in? That will definitely be option B, which is the answer here. Question 9. The sum to infinity of a GP is minus 1 over 10. So sum to infinity is equals to minus 1 over 10. And the first term is minus 1 over 8. The first term is minus 1 over 8. Find the common ratio. The first thing we need to note here, we have to look for the common ratio. So here, what is the formula connecting the sum to infinity, the first term, and the common ratio? The formula is sum to infinity equals to A over 1 minus R. This formula is very important here because once this formula cannot be recalled, then it is very difficult for us to figure out our answer. So in this situation, since we know this, then our sum to infinity has been given. That is minus 1 over 10. Then what is our first term? Our first term is minus 1 over 8 divided by 1 minus R. And the question asks us to look for what? The common ratio, which is our R. In this situation, we know that we have to be very careful if we are to solve this problem. This is minus 1 over 10 equals to minus 1 over 8 divided by 1 minus R. So let's cross multiply what we have. So by cross multiply, I have minus 1 into 1 minus R on this side equals to 10 times minus 1 over 8. Let me use this minus to open this. Minus 1 times 1, minus 1. Minus 1 times minus R, that's plus R, equals to 2 here 4, 2 here 5. So I have minus 5 over 4. I'm looking for my R. So let me transfer this one to the other side. I have R by collecting like terms. So I have R to be minus 5 over 4 plus 1, because this is minus 1. Once it crosses the bridge, it will become plus 1. So you have this. Then what is this? Let's find the LCM here. What's the LCM of 4 and this? 4 and 1, 4. How many 4 are we going to see in 4? 1. 1 times minus 5, minus 5. Plus 4 in this. 1 in 4. 4. 4 times 1, 4. So I have R to be equals to this. So my R will be minus 5 plus 4. That's minus 1 over 4. So my common ratio will definitely be minus 1 over 4. So I go to my option and see the one that suits. That is option B. So I move to the next one, which says that find the sum of the first 8 terms of this sequence. Remember, look at this. This is a sequence. And if you look at this sequence closely, you discover that the sequence, the last term of the sequence is given. Why? Because you have a 36 and a dot to show that this is where it terminates. So in that situation, this is the trend. So you have find the sum of the first 18 terms of the sequence. The first question you ask yourself is that is this sequence in GP or AP? Because there are the formula for the sum of AP is quite different from that of GP. So that means we cannot just assume. So we need to test or we need to confirm whether this sequence is in AP or GP. So how do I know whether it is in AP or GP? If the sequence is in AP, the second term minus first term must definitely be equal to the third term minus second term. That is the condition for AP. So let's see. Where is it? What is the second term? The second term here is 6 minus the first term. What's the first term? 3. Must be equal to the third term. What's the third term? 9 minus the second term, 6. 6 minus 3, 3. 9 minus 3, 3. So automatically, since the left hand side is equal to the right hand side, automatically this sequence is in AP. So since I've now confirmed that the system is in AP, then the next thing to do is to look for the sum of the first 18 terms. And look at the question closely. Our common difference is now known. So in that situation, I will write the formula for calculating the sum of AP first. The sum of AP is number of terms over 2 into 2a plus n minus 1 brackets d. Remember that for this particular question, the last term is known. because the two formulae for calculating the sum of AP are this, and the second one is this. I gave that in when I was talking about the topic itself. So I gave these two formulae. So I told you that there are two formulae for calculating the sum of AP. The first one is when the last term is not given, while the second one is used when the last term is given. Following this trend, this sequence, we discover that since there is a comma here, it shows that this 36 is no longer the last term. So based on these two formulae, since this 36 is not the last term, we cannot use this one. Rather, will result into using this one. So in that situation, what it simply means is that what are the information that we know already? We know that our common difference is 3 by virtue of this conformation. Then we also know our first term from the sequence to be equals to 3. Now, the number of terms has been given. It's said 18 terms, so 18. Then, which other parameter are we looking for? There is no other parameter. So let's use this very formula. So we have Sn to be equals to n, that's 18 over 2, into 2. What is our first term? Our first term is 3, plus n. N, what's our n? 18 minus 1. What's our d? Our d is 3. Then from here, we can simplify this. 2 here 1, 2 in 18, 9. So we have 9 here. Then this is 2 times 3, 6. Plus this one is 18 minus 1, 17. 17 times 3, that's what I'm going to have. Then we have Sn to be equals to